Hi all, myself Dr. K. Ashok, Associate Professor of Physics, Marri Laxman Reddy Institute of Technology and Management. My area of research is piezoelectric materials. Today I am going to discuss about the bipolar junction transistor and its operation. Bipolar junction transistor. Basically, it is a three-terminal device which amplifies the electrical signals and television signals. The transistor symbol, the modern days whatever we are using, that you can see here. This transistor was invented by William Shockley, Bardeen and Brattain. These three scientists in 1947, Bell Laboratories, they invented this one. Before this transistor, actually we are using vacuum tubes. The major drawback of vacuum tubes is their size. They are bulk in size. So they consumes more power, they occupies more space and everything. These all are the disadvantages. To overcome these disadvantages, the modern days, these transistors we are using. That's why initially when we developed our computer, it occupies three rooms. For entering input one room, for processing another room, and result getting is the another room. So this much of space is occupied. Later on, the development in transistors causes the entire computer comes into our pocket as a cell phone. Basically, the transistor consists of three parts. First one is emitter. Emitter is heavily doped. When we consider in terms of the doping, emitter is heavily doped so that it provides majority charge carriers. The middle section of the transistor is called base. The base is lightly doped. And when we consider area point of view, the base is very thin. Next, coming to the third part of the transistor is called collector. So collector, when we consider doping point of view, collector doping is moderate in between emitter and base. Since emitter is heavily doped, base is lightly doped, in between moderately the collector is doped. The collector function is to collect the charge carriers which are injected by the emitter. The base controls the flow of the charge. So consider here emitter. Emitter provides majority charge carriers which is heavily doped. Coming to the base, base controls the flow of the charge carriers which is lightly doped. Coming to the collector, collector is moderately doped which collects the charge carriers from the emitter. When we consider the size of these three parts, collector is the largest size as it collects the charge carriers from the emitter. So when the charge carriers are enter into the collector, some heat will be generated. To dissipate the heat, the size of the collector is large. Here you can observe the real time what we are using the transistor. So basically the transistor consists of two junctions. This is junction 1 and this one is junction 2. The junction between emitter and base is called junction 1. This is also known as emitter base junction. The junction between base and collector is second junction. This is also known as collector base junction. There are two types of transistors are available. First one is PNP transistor. Here N-type semiconductor is sandwiched between the two p-type semiconductors. And another one is NPN transistor. A p-type transistor, p-type semiconductor is sandwiched between the two n-type semiconductors. See the circuit symbol here, PNP transistor. Here you observe the direction. This is inward. That shows the current direction. And here when you consider NPN transistor, here see the arrow mark is outside which shows the direction of the current. In NPN transistor, the current is flowing base to emitter side, and in PNP transistor, the current is flowing emitter to base junction. Now we will observe the bipolar junction transistor operation. See here in the name bipolar. What is the meaning of it? Bi means two here. Polar means two types of charge carriers like electrons and holes. Both are involved. That's why this is bipolar junction transistor. See in the name transistor. Transistor is nothing but transform resistor. Transform resistor. Here you observe in this presently we are considering NPN transistor. NPN transistor here it is like junction 1, that is emitter base junction is forward biased. What is the forward bias? When N side is connected to negative terminal of the battery, P side is connected to positive terminal of the battery, then that is nothing but forward bias. When we consider junction 2, that is nothing but collector base junction. Collector base junction is reverse biased. Emitter base junction is forward biased. Collector base junction is reverse biased. Here P side is connected to negative terminal of the battery. N side is connected to positive terminal of the battery. That's why this is reverse biased. We know very well in the previous class we discussed forward bias is low resistance connection. Here actually the junction will be formed, like depletion layer will be formed, but the depletion layer is thin. Why? Under forward bias, the charge carriers are moving towards the junction. Then the width of the depletion layer is decreasing. When the depletion layer width is low, then it offers low resistance. And this PN junction here, this is reverse bias. That's why the width of the depletion layer is high. So width of the depletion layer is high means obviously resistance is high. Resistance is high. Here the resistance is low. Indirectly, we are moving charge carriers from low resistance to high resistance. That's why transform resistor. Here trans we took from transform and ester we took from resistor. Both we mix and we call it as transistor. So totally bipolar junction transistor means two types of charge carriers involved, and the current is moving from indirectly, the charge carriers are moving from low resistance to high resistance. Now we will observe the operation of the NPN transistor. NPN transistor. In N-type semiconductor, the majority charge carriers are electrons, minority charge carriers are holes. In P-type semiconductor, majority charge carriers are holes, minority charge carriers are electrons. And this one, collector region, N-type semiconductor, here majority charge carriers are electrons and minority charge carriers are holes. Here this N is nothing but emitter and this P is nothing but base and this one is collector. So here emitter base junction is forward bias and here this collector base junction is reverse bias. Here the negative terminal of the battery repels the electrons. So these electrons are moved towards the junction. Since the base is lightly doped, some of the electrons are recombined with holes in P region and remaining some of the electrons will get attracted in this direction because here positive terminal attracts these electrons and majority of the electrons gets crossed from this base to collector. Here the collector is connected to positive terminal so that these electrons will move in this direction and constitutes a current IC. Whatever the electrons are moving in this direction, they constitute a current IB. So here we can apply Kirchhoff's current law, KCL. According to KCL, sum of the input currents is equal to the sum of the outgoing currents. When we consider emitter base junction, from emitter the electrons are moving in this direction. That's why the direction of the current is in this direction. Conventional current direction is IB is okay left side. When we consider like base, in the base the electrons are moving downward. That's why the direction of the current base current is upward. In the collector, the electrons are moving in this direction. The conventional current is towards the left side. So, here when we observe, according to KCL law, here if we apply KCL law, simply emitter current is equals to sum of the base current and collector current. This BJT can be operated in different modes of operations. When we consider different modes of operations, here emitter base junction is there, first one, and collector base junction is there, then region of operation region, emitter base junction if you do forward bias, collector base junction if you do reverse bias, then the diode like bipolar junction transistor in active mode. This active mode operation of the transistor is in amplification purpose. Amplification purpose we will use. Even you can do this one is forward bias. Again, even collector base junction also forward bias. When both junctions are forward bias, then this state is called saturation state. So saturation state is nothing but logical on. Logical on means switch is closed. Emitter base junction can be reverse biased. Collector base junction is forward bias. This state is called cutoff region. Cutoff region. Cutoff region is usually used logically half means switch is open. Last state of operation is reverse bias emitter base junction, forward bias collector base junction. So here the collector and emitter roles are inverted, but this is rare cases we will use in our situation. So this is about the BJT. So when we consider advantages, what is the advantages of using these transistors? When we consider vacuum tubes, initially we discussed its size is very large, so it occupies more space, it consumes more space, it produces more heat also. So consider this transistor size is small, so the power consumption is low. When size is reduced and even the transistor is made up of with diode, the diodes are based on silicon. The silicon is available from sand whose cost is very low. That's why these can be developed with low cost. And the size is low and higher efficiency. Efficiency means whatever the output we are getting by supplying the input. It is the ratio of output by input which is very high. It produces very less heat compared to vacuum tube as its size is small. Transistors are lighter as its size is small compared to the vacuum tubes. What are the applications of this BJT? BJT can be used as a amplifier to increase the strength of the weak signal or to decrease the strong signal. So you can amplify the signal. Even this can be used as a switching circuits. So in switching circuits, we can use it as a switch. This BJT we will use in microprocessors and in computer memories. So whenever we consider a processor, there the Intel chip, in 1 inch we are keeping 2 billion transistors. This transistor is like neuron, how neuron in our brain, like that only same this a transistor for the computer memory. They are used in smartphones, even they are used in cameras. So this is about the completely bipolar junction transistor applications.